Hello guys, in this video I'm going to show you how to solve smallest number range problem. So given M sorted arrays, find the smallest range that includes at least one number from each of the M lists, right? So for example, with this given input, we have M lists, we have three lists here. So as you can see, each list is sorted by itself, right? 1 by h is sorted in ascending order. Same here, same here. So find the smallest range that includes at least one number from each M list. So the range that include one number from each list. So for example, 147 is a possible range, right? Which includes one number from each list, and the range means the difference between the smallest number and the largest. In this case, it is 1 and 7. The range is 6, right? So here is a possible range, but what we want to find here is the smallest range, right? So it can be anything in, for example, it can be 148. Probably not, because 147 will beat 148, right? It could be 4, 5, 7, for example, and it could be 4, 5, 8. Not, probably not, because 4, 5, 7 will beat 4, 5, 8, right? 4, 5, 7, the range is the difference between the smallest is 4 and the largest is 7 is 3, right? 7 minus 4 is 3, right? Yeah, so there are different others as well. 5, 7, 12, for example, but probably not, because 12 minus 7 is 5, right? Which will not beat the other one, like 4, 5, 7. So basically, we kind of we need to check, right? We need to check different set of numbers, right? And each set of number each set of numbers that we consider will need to include one number from each, right? From each list. So the idea here is when we need to check a set of numbers from each list, right? And each list is sorted. We can use a heap, right? We can use a heap here to check different set numbers. For example, we started 1, 4, and 7 is one possible list, right? The first set will be the first number from each list, right? 147, right? So what would be the next set here? Um, how to find the next set? Because it is given that each list is sorted by itself. So the next set will be uh, how to say, the next set will to find the next set. Where I will look at the previous set. I want to take out the smallest number, right? Okay, and we have 4 and 7 there. We take out the smallest one, and we look at we ask questions. Where is the smallest one come from? It come from this uh, list, right? So the next of 1 is 5. So 5 will be the next number, right? By doing this, we are kind of like uh, checking like all the possible set of numbers, right? Different kind of combinations, right? We check different combinations, and we probably want to calculate the difference here. For example, for the first combinations, the difference is the range is 7 minus 1 is 6, right? And for the next one, it will be 7 minus 4, so it's 3, which is better than 6, right? We need smallest range. What would be the next combinations? The next combinations, what is the smallest number from previous combinations? Is 4. So I take out 4, let's find 7. And what is the next of 4? It is 12. So I have 12 here. We have another combinations that every number in combinations will come from one list, right? 5 from this list, 7 from this list, and 12 from this list, right? So again, 12 minus 5 is 7. 5 minus 12, 12 minus 5 is 7. Okay. So 7 will not be 3, which is the currently smallest range. What will be the next combinations? What is smallest one? Which is 5. I will fire 7, 12. So we remove 5, right? And what is the next of 5? It is 8, right? So this will be the new combinations, and the difference will be 12 minus 7 is 5, which will not be 3. Yeah, right. Okay, next. What is smallest here? 7, right? We left 8 and 12. What is negative 7? Negative 7 is 8. -70s, right? So as you can see here, we have 2 8, right? But come from different lists, so it's okay. We just need to find the difference here. 12 minus 84 will not be 3 here, right? Uh, so 8, what is smallest one here? 8, right? So we left with 8 and 12. 8 and 12. So we take 8 here out, and we are left with 8 and 12 here. So what's the next of 8? Is 10. Okay. So difference is 12 minus 8 is 6, right? Which will not be 3. Smallest again 8. So I take 8 out, 10. But here we couldn't find the next of the smallest, which is 8, right? There's no next number of 8 because 8 is the last one in this array. So from here we can't find a combinations that include one number from each of list, right? So when this is the case, I probably want to start processing, right? So that is it, right? Try to process different combinations, right? To find the best range. So as you can see, as we by doing this kind of processing, we need to keep track of what is smallest number, right? So for that kind of task, we can use a heap, of course, right? And yeah, and also for each batch processing, we need also the largest number as well, so that we can calculate what is the current range, right? So we have to notice here smallest with the new heap and largest. We probably want to keep track this one, keep track. So the heap will give us the smallest number, right? But while adding more number to the heap, right, we can also keep track of the largest as well, so that when we have a combinations, we know the smallest and we also know the largest, and when we find the difference. Okay. um, okay, and also here, not just we need to keep track of where uh, where a number from, right? Where a number from a number come from, right? For example, here this set, right? We want to find the next combinations. We find the smallest, which is 1. So we look at here. We must know 1 come from this list, so that we can add 5 to form a new combinations. Okay. So mm, where number come from and what is its current position. So one come from the first list and its positions is index 0, for example, so that we can, okay, what is the next of index 0? It's 5, which is index 1, right? So this one we can abstract it out into a node, right, that contain information needed, right? So for example, class node constructor, we need what? The value itself, the value. This will take from the argument. We need number index, right? Also take from IDX is index short for index, and value num index and list index, right? List index will be from list index. Okay. Okay. So we need a heap, right? It's a mean heap, right? We need keep track. We need to get access to the smallest one, right? But the thing that is pushed into the heap is not the number itself, but the node, right? Because we want these two pieces of information, right? So the third argument will be a callback functions. Text in A and B. A and B here is just two nodes, right? And because it's mean heap, so it will be B minus A. But here we need to compare the value, right? A and B is not instance. So wow, okay, we have a mean heap, okay, and we need a initial state of mean heap, right? Which is like this one, this guy. We need first number from each list, right? So simply by looping through each let let's say let's call this one array. We have array of lists, right? So let list of array. So here, for example, I will look at the test. Right? The functions will take in an array of lists, right? Okay. So we need the first number from each list, right? List at index 0. Here is the value itself, right? We want to add to the heap instead. Heap. Okay. We need to import the heap from the library. Okay, heap. Let's make it mean heap. Okay. So we add the first number to the heap, right? But we want to add the node instead. So the node we have the value which is the list index 0 and number index will be 0, right? List index, we don't have the list index here, so here we can use entries, right? In here I will look through an array, and the first can destructure into list index and list itself, right? So here I can pass in list index, right? Okay. Okay, we're done. Initial state. Initial state. Okay, I have initial state, right? So because mean heap will give us smallest number, we need the largest, the current largest number. Let's say that's largest. I can initialize it with minus infinity, a very small number. So that for the first number, right, the first number will always larger than this one, whatever it is. Okay. What I need to do next is, okay, I need to, as you can see here, we need to get into a loop. Get into a loop here. What is conditions? Probably I want to loop as long as the size of the loop is equal to, like, is m, like we have mlets here, so we need to be sure that we have m item in the heap, right? And each item will come from one list. So if it's no longer true, I will exit the loop, right? So mean heap dot length will have to be at least, right? Can be largest? No, probably equal to the array. No, yeah, array dot length. Okay. So we need to keep track of what we need to return here is actually the range. We don't need this value. We don't need the difference, but we need the range, right? So let's say we need to keep track the the current range. The largest we can keep track of this value, right? We can calculate this value from largest, and the smallest in the min heap. um, okay, so we can calculate difference, current difference. If the current difference is less than um, the minimum, less than currently smallest range, currently smallest difference, right? Then I will update the new range, which is smallest number and largest number currently. Okay, I need smallest difference. Smallest difference will be infinity with very large number. Okay, so at any given point in time, we always have m number in the heap, right? And each number will come from one list, right? So at the beginning of the loop, I probably want to process the current combinations. So I ask like, what is the different current diff? It will be calculated by uh, the largest minus the smallest, which is smallest will be the min heap pick, right? Min heap will always give us the smallest number, and here we'll return a node instead. So I need to dot about the largest. Here is infinity, probably not, but I want to move this up, right? Because we start with this initial state, right? So we want to start update the largest as we adding new node to the min heap, right? So for example here, if now we can update the largest, will be we compare the current largest max, right? Max. We compare current largest with the new value, which is this index 0. And if it is equal find the largest and update the largest here currently, current largest. Okay, so after this loop, we have the largest being set here. So here I can take largest minus smallest. Okay, I can check the current diff if it's less than smallest diff, which is always the case for the first iterations. So if it is the case, I will first update the smallest to the current diff. Now smallest diff to current diff, and I will need a range also. Range after range. Range will be two number. Initially, let's say -1 and -1. So the range I will update here. It will be smallest and largest. Okay. Now I will update the range here. Now we return the range at the end. So after find the current diff, and probably update the range. If it currently is latent, the currently smallest diff, I will update the small diff to the current. Okay, the range will be the new range. Okay, that's awesome. Next, we need to find the next combination. Right. The next combination how to find. I need the smallest number, which is smallest value is here. I need not the smallest value L, right? Not L will be min hit dot pop. Okay, I can destructure it out here to value what here, number index and list index also. So okay, so we need to pop it out already, and I need a new numbers come in, right, before the next loop, so that we have the heap with m numbers. Each number comes from one list. So I need to find the next number for this node L. So we have num index and list index here, right? So list index here. So I can access to the list. It will be a cycle list is array at list index. Okay, here is the list of this node L. So we need to find the next number for this one, but it can be the case that we don't have this next number. If it's the last number, so I need to check the index, num index here. I want to make sure that num index plus 1, which is the index of next number of this node L, if this is still in the range of the current list. If it's still less than or equal to current current list dot length. Okay, then I want to add a new one to the min heap here, which is a new node with the value is current list, not current list instead, at index, which is num index plus 1, which is the next index, num index plus 1. Okay, the index of new node will be num index plus 1, and the list index will be the same, right? Here, list index. Okay, but don't forget to, as we add new number to the min heap, I want to do the same here, which is update the, I want to update the largest, right? So it will find the max of current largest and the new one that comes in, which is what is that? This one. Okay, so we don't need this. Sorry. Okay, I think that is right. So as long as we don't have a new node, this is not the case. I don't run into these braces, and I don't have new knot uh, added to the mean hip. Here, the mean hip side will no longer equal to this aimless, right? So uh, then I will exit the loop here. I will return the range. Okay, that makes sense. So let's run the test. Just 14. Okay, we merge 4. Okay, hopefully. Uh, mm, hmm. Okay, it works. Awesome. Just try to break it with to make sure that. Okay, it works. Awesome. So that is it for this video. Uh, thanks for watching. See you in the next one.